The ground wire wrapped around service entrance cable does not provide the physical protection required by code. According to the National Electrical Code, cables installed within 1.25 inches of the edge of a stud or joist must be protected by conduit or other approved means. This is to protect the cable from being punctured or damaged by nails or screws. The ground wire in service entrance cable is intended to provide a path for fault currents, not to protect the cable from physical damage. It is not as thick or robust as the insulated conductors and may not be able to withstand puncture or crushing forces. While a circuit breaker will protect the cable from electrical overloads, it will not provide physical protection from damage. The breaker is designed to trip when the current exceeds a safe level, but it cannot prevent damage caused by punctures or cuts. To comply with code and ensure the safety of an installation, several options exist. Firstly, install conduit along the length of the stud and run the service entrance cable inside it. Secondly, use metal or plastic stud clamps to secure the cable to the stud, ensuring at least 1.25 inches of clearance from the edge. Thirdly, use an armored cable such as BX cable that provides its own physical protection. Fourthly, if possible, relocate the cable to a location where it does not need to run within 1.25 inches of the stud edge. The code mandates physical protection for cables near studs to prevent damage from nails and screws. The ground wire is for fault currents and the circuit breaker protects against overloads, not physical harm. Options for compliance are using conduit, stud clamps, armored cable, or relocating the cable. These measures ensure the cable's safety in compliance with electrical codes. Ensuring proper electrical installations is essential for safety. Incorrect installations can lead to hazards such as electrical shocks or fires. Electrical codes are designed to minimize these risks. Cables running close to studs are vulnerable because nails and screws used in construction could penetrate them. This penetration could damage the insulation of the conductors, causing a short circuit or ground fault. A short circuit happens when electricity flows outside of its intended path. A ground fault occurs when electricity unintentionally flows to ground. Both situations can be dangerous. The National Electrical Code, or NEC, is a set of standards and guidelines for safe electrical installations. It is updated every 3 years. Local jurisdictions adopt and enforce the NEC or create their own electrical codes based on it. The NEC specifies how cables must be protected when they are installed near studs. One common method of protection is to install the cable inside a conduit. Conduit is a metal or plastic pipe that encases the cable and shields it from physical damage. Another method is to use stud clamps. Stud clamps are devices that secure the cable to the stud while maintaining a safe distance from the edge. Armored cable provides a layer of metal protection around the conductors. If it is not possible to use conduit, stud clamps, or armored cable, the best option might be to relocate the cable. Moving the cable to a location where it is not exposed to the risk of physical damage can be a simple and effective solution. Understanding the purpose of each component in the electrical system is crucial. The ground wire in service entrance cable is designed to provide a low impedance path for fault currents. This helps to ensure that the circuit breaker will trip quickly in the event of a fault, minimizing the risk of electrical shock or fire. Circuit breakers protect against overcurrents. An overcurrent occurs when the current in a circuit exceeds the rated capacity of the conductors. This can happen due to a short circuit, a ground fault, or an overload. The circuit breaker will interrupt the flow of current, preventing damage to the equipment and reducing the risk of fire. The NEC specifies the types of cables that can be used for various applications. Service entrance cable is designed for use in bringing power from the utility service to the building. It is typically installed outdoors and must be resistant to weather and physical damage. The installation of service entrance cable must comply with all applicable codes and regulations. Working with electricity can be dangerous. Always take precautions to protect yourself from electrical shock. De-energize the circuit before working on it. Wear appropriate personal protective equipment. If you are not comfortable working with electricity, hire a qualified electrician. Inspectors ensure that electrical installations comply with codes and standards. The inspector will review the installation to identify any potential hazards or code violations. If violations are found, the inspector will require them to be corrected. Electrical safety is everyone's responsibility. By following codes and best practices, you can help to prevent electrical accidents. Always ensure that electrical work is performed by qualified individuals. Do not attempt to perform electrical work if you are not properly trained and equipped. Regularly inspect electrical systems for signs of damage or wear. Replace any damaged components promptly. Use ground fault circuit interrupters or GFCIs in areas where there is a risk of water exposure. A ground fault circuit interrupter is a device that detects ground faults and interrupts the flow of current. This can help to prevent electrical shock. Educate yourself and others about electrical safety. The more you know about electricity, the better equipped you will be to protect yourself and others from its hazards. Common electrical hazards include overloaded circuits, frayed wires, damaged outlets, and wet environments. Overloaded circuits can cause wires to overheat and potentially start a fire. Frayed wires can expose live conductors, creating a shock hazard. Damaged outlets can also create a shock hazard. Wet environments can increase the risk of electrical shock. Be especially careful when working with electricity in wet areas. By taking these precautions, you can help to ensure the safety of your electrical installations. The electrical codes and regulations are in place to protect people and property from electrical hazards. Always comply with these codes and regulations. If you have any questions or concerns about electrical safety, consult a qualified electrician or electrical inspector. Regular maintenance of electrical systems is crucial for preventing hazards. Schedule periodic inspections to identify and address any potential issues.